Hello everyone, welcome to solve this nice math Olympiad exponential equation problem. So here we have 6 to the power of c minus 5 to the power of c is equals to 11, and we solve this problem for all the values of c. So here the very first thing we are going to do is first we need to multiply and divide the exponent of both of these two terms by 2, and when we multiply and divide by 2 it will be written as c to the power of 6 over 2 multiplied by 2 minus, in the same pattern we multiply the exponent of this term is also 2, and it will becomes here c over 2 multiplied by 2 is equals to 11. And now here further we use the nice exponential law. You know about this law. If we have uh, a to the power of m to the power of n, or in other words, if we have the product of two exponents, a to the power of m multiplied by n, we write it as a to the power of m to the power of n. Okay, so according to this rule, here we just move the term c over 2 inside the value, and it will be written as c to the power of 6 over 2 and its whole square minus, in the same pattern we move the c over 2 inside the term, and it will be written as 5 to the power of c over 2 and its whole square is equals to 11. And now further in the next step here we need to take little bit more simplifications here, so that we will substitute, or we will take the base of this term, that is a is equals to 6 to the power of c over 2, and we take b is equals to 5 to the power of c over 2. So here when we substitute these two values of a and b into the above equation, so it will be written as, so when you put this value here it will becomes a square, minus when you put this value here it will becomes b square, and this is equals to 11. And now you see here in the left hand side we get, this is the very famous algebraic formula. We know about that a square minus b square is equals to a minus b times of a plus b is equals to 11. So here our target is to find the values of c, but for the values of c first we need to find the value of a or the value of b. We need to find any one value of both of these two terms, and then we move back substitution and we get the value of c. So here we just find the integer values of c, so that here in the left hand side you see here these two factors are multiplied by each other in the left hand side, but in the right hand side we have, this is only one factor, so we need to make two factors on here. So for this we find any two numbers whose product becomes 11. So these two numbers are 1 multiplied by 11 is equals to 11. Okay, so here if we make the relation between a minus b and a plus b, we write it as a minus b is always less than a plus b. So here according to this rule we compare the left hand side with right hand side, and you see here our, when you compare both of the sides we will get a minus b is equals to 1, and we will get a plus b is equals to 11. So further in the next step here we need to just find the value of a, and here we will call this is equation number 1 and this is our equation number 2. So we sum up equation number 1 and equation number 2. When we sum up both of these two equations, we will get here a plus a becomes 2a, and this minus b and plus b are gone, and we get here 1 plus 11 becomes here 12. So further in the next step we need to find the value of a. For this we remove this 2 from here, and in order to remove this 2 we will divide both of the sides by 2, and when we divide by 2 it will becomes here in this form. So this 2 and this 2 are gone, and we get here our a is equals to, this is 2 times 6 becomes 12, and this is the value of a which we get here in this question. Okay, so here because here our target is to find the value of c, so for this we substitute back substitute the value of a. In the start of the problem we will take here our a is equals to 6 to the power of c over 2. We back substitute this value of a here, and this a equals to 6 implies that When you put the value of a, it will become c to the power of 6 over 2 is equals to this is 6 only. So here further in the next step we have here we you see that the exponent of this term is 1, and you see that the bases on both of the sides are same, so that we equate its exponents, and when we equate its exponents it will becomes here c over 2 equals to 1. So these two exponent becomes equal, and this implies that here we move this 2 from left hand side to the right hand side, and it will becomes c is equals to 2, because 2 multiplied by 1 becomes here 2. So here in this question we get this is the only one value of c which we get here. So now in the next step we need to verify that is this value of c be the solution, or is this value of c be the extraneous root. So for verification of this value we need to copy down given question statement here, and the given question statement is 6 to the power of c minus 5 to the power of c is equals to 11. So here we substitute the value of c, and the value of c is equals to 2. So when we put c equals to 2 here, it will become c square minus 5 square is equals to 11. And we have c square becomes 36 minus 5 square becomes 25 is equals to 11. So 36 minus 25 becomes here 11 equals to 11. So this shows that both of the sides are equal. It means that the above value of c is equals to 2 is satisfied our given question statement. So finally we have the solution set of this problem is c is equals to 2. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.